There are moments when a single transmission from the void can freeze an entire team of scientists in silence. Not because of what it says, but because of what it refuses to explain. Voyager 1, humanity's most distant emissary, drifting now at nearly 26 billion kilometers from Earth, has just sent what may be its final coherent burst of data before power fades forever. But this transmission did not carry the expected calm readings of interstellar plasma or cosmic rays. It carried something urgent, something patterned, something that reads like a warning carved into binary by a machine that has seen too much. As the signal crawled across the light hours toward us, arriving after nearly a full day of travel, the numbers aligned in ways that defied random degradation. They aligned in ways that suggested the spacecraft itself understood it was reaching the edge of its existence and wanted us to know what waits beyond. Voyager 1 was never designed to speak this long. Launched in 1977 on a mission measured in years, not decades, it was built to photograph gas giants, skim rings, and then fade into quiet irrelevance. Its radioisotope thermoelectric generators, powered by decaying plutonium-238, lose about 4 watts per year. By 2026, only a handful of instruments remain alive. The magnetometer mapping interstellar magnetic fields, the plasma wave subsystem listening to the whispers of charged particles, the low-energy charged particle detector tracking cosmic rays. The cosmic ray subsystem itself was powered down in early 2025 to conserve what little energy remains. Yet even as power ebbs, Voyager continues transmitting engineering data, faint but persistent, from a region where no human artifact has ever lingered this long. And in recent months, as it approached the symbolic threshold of 1 light day from Earth, achieved around late 2026, the probe's behavior shifted in ways that have left engineers staring at screens in disbelief. The trouble began quietly, as these things often do. In late 2023 and into 2024, Voyager suffered a notorious glitch. Its flight data subsystem corrupted a memory chip, turning scientific streams into repeating patterns of 1s and 0s, gibberish that mocked every command sent from Earth. NASA engineers, working from decades-old blueprints, painstakingly relocated code, bypassed the faulty sector, and restored communication by mid-2024. It was a triumph of ingenuity over entropy. But as the spacecraft pushed deeper into the local interstellar medium, new anomalies emerged. Not catastrophic failures, but subtle, persistent deviations that grew harder to dismiss as aging hardware alone. Interstellar space is not empty. It is a sea of dilute plasma, threaded by magnetic fields that twist on scales spanning light years, bombarded by galactic cosmic rays accelerated in supernova remnants and black hole jets. Voyager 1 crossed the heliopause, the boundary where the sun's influence yields to the galaxies, in 2012, registering a sharp drop in solar particles and a surge in high-energy cosmic rays. The magnetic field orientation shifted, plasma density rose unexpectedly, and pressure waves rippled through the medium like echoes of distant stellar explosions. Recent data, as of 2025 and early 2026, reveal even stranger structures. Transient compressions in the interstellar plasma, abrupt jumps in magnetic intensity, and anisotropies in cosmic ray arrival directions that hint at nearby sources or filamentary currents in the local interstellar cloud. These are not the smooth gradients theorists once predicted. They are dynamic, turbulent, almost responsive. And Voyager's final transmissions appear to capture the moment when these forces reached a crescendo. One of the most unsettling patterns arrived in the plasma wave data. The subsystem, designed to measure electric field oscillations in the surrounding plasma, has long recorded eerie sounds, converted frequencies that evoke whistles, chirps and hums when shifted into human hearing. But in the latest downlink sequences, before power constraints forced further throttling, the waves exhibited prolonged, rhythmic modulations that did not match known interstellar turbulence or solar cycle influences. These were not random bursts. They formed harmonics with precise intervals, repeating across multiple communication passes separated by days. Engineers first attributed them to interference or cosmic ray hits flipping bits, but cross-correlation with the magnetometer showed synchronized distortions. The interstellar magnetic field lines bending in concert with the plasma oscillations, as if something massive or structured was compressing the medium around the spacecraft. Then came the attitude control anomalies. Voyager maintains Earth lock through a delicate dance of hydrazine thrusters, firing microbursts to counteract drift. In 2025, engineers revived backup thrusters dormant since 2004, fearing residue buildup in the primary lines could clog them irreparably. The revival worked, a minor miracle across billions of kilometers. Yet shortly afterward, telemetry showed uncommanded corrections. The spacecraft realigning its high-gain antenna with precision that exceeded expected mechanical tolerances. No thruster firings were logged. No external torque from solar radiation pressure or micrometeoroids could account for it. The corrections occurred during periods of heightened plasma wave activity, as if the surrounding medium itself was exerting a stabilizing influence, or something within it was intervening. Cosmic rays provided the next layer of unease. Voyager's low-energy charged particle instrument, still operational into 2025 before its scheduled shutdown, detected fluxes that spiked irregularly, not in the isotropic drizzle expected from galactic sources, but in directed beams with angular preferences. These anisotropies, noted in recent analyses of local interstellar medium data, suggest Voyager is traversing a region where cosmic rays are funneled or focused, perhaps by magnetic bottles or shocks from past stellar events. But the timing is ominous. The spikes coincide with the rhythmic plasma modulations and magnetic kinks. If interstellar space harbors unseen structures, filamentary clouds, relic magnetic domains, or even hypothetical dark matter concentrations, these readings could mark Voyager's passage through one. And the final transmission captured the peak, a burst of elevated cosmic ray intensity, followed by a sudden drop, as though the spacecraft had crossed a boundary into a quieter, more ominous void. The most chilling element lies in the engineering telemetry itself. Amid housekeeping data, temperature readings from the plutonium bricks, voltage levels from the fading generators, appeared sequences that resisted explanation as mere noise. Binary strings with embedded repetition, error correction-like patterns, and timing that mirrored Voyager's own transmission cadence. NASA has not confirmed artificial origin. Official statements frame it as probable corruption or environmental upset. But within the Deep Space Network logs, analysts noted the patterns arrived only after routine beacon pings, as if the spacecraft, or something monitoring its signals, waited for confirmation of receipt before embedding the message. The final coherent packet, the one that gives this video its title, contained a rapid cascade of status flags: power critical, instruments nominal yet strained, magnetic field anomaly sustained, particle flux threshold exceeded. Then silence, not abrupt cutoff, but a deliberate tapering, as though the probe conserved its last electrons to ensure the warning reached home. Consider what this means. Voyager 1 has outlived every expectation, surviving radiation belts that should have fried its circuits, decades of thermal cycling in vacuum, the relentless erosion of power. It has mapped the heliosphere's turbulent edge, revealed the heliopause as a violent shock front rather than a gentle fade, and now probes a region where the galaxy's raw physics dominate. Its data suggest the interstellar medium is far more structured, far more active than models allowed. Transient pressure waves, magnetic amplifications, directed cosmic rays, these could be natural. They could also hint at processes we have no framework for. Interactions with unseen matter, echoes of ancient cataclysms, or boundaries between our local bubble and deeper galactic arms. And as Voyager's voice grows fainter, approaching the point where even one instrument will shut down forever, its last words carry an implicit alarm. The universe beyond our shield is not passive. It is alive with forces that can bend fields, channel particles, and perhaps notice a tiny interloper drifting through. We stand at the threshold of losing our only direct witness to this frontier. By late 2026 and into the years beyond, Voyager 1's signal will grow too weak, its power too scarce, for meaningful data return. The one light day milestone marks not just distance, but isolation. 48-hour round-trip delays, where commands sent today arrive tomorrow and responses lag another day. What Voyager has already transmitted may be the final unfiltered glimpse of interstellar reality before humanity's reach retreats. The patterns in its data, the rhythms, the spikes, the uncommanded stabilizations, whisper that something out there is dynamic, perhaps watchful, perhaps indifferent, but immense. If these are warnings, they are not of invasion or malice, but of scale. A reminder that our solar system is a fragile island in a churning cosmic ocean, and crossing its boundary exposes us to truths our equations have yet to grasp. Pause and feel the weight of that isolation. A 1970s machine, held together by code older than most living engineers, has traveled farther than any dream, seen things no human eye will ever witness directly, and now, in its dying breaths, sends back a message that chills because it is so understated. Not panic, not explosion, just data that refuses to fit, patterns that suggest the void is structured, active, unforgiving. Voyager 1's final transmission does not scream danger. It simply states fact. We are small, the galaxy is vast, and what lies beyond our sun's protection may rewrite everything we believe about our place in it. If this journey, this fragile thread of communication across the abyss, moved you, if the thought of a lone probe, whispering warnings from the edge, shakes something deep inside, then stay with this exploration. Subscribe, because the story of Voyager is not over until its last electron fades, and every update could reveal more about the unknown that awaits us all. Like if the quiet courage of this ancient machine inspires you. And in the comments, tell me, when Voyager's signal finally goes silent, do you believe it will have warned us of peril, prepared us for wonder, or simply reminded us how fragile and how brave our curiosity truly is?